Hello everyone, welcome. In this video we are going to look at multinomial probability. So this multinomial probability is you can say generalization of the binomial probability. In binomial probability we have two outcomes. The possibility of outcome is two, right? Either it could be a fail or it could be a pass. Or if we think in terms of our coin tossing model, so we are doing the experiment, either we can get the head or tail. So there are two possibility of outcome, right? But in case of multinomial probability we will be dealing with outcomes that will be in general maybe our kind of outcome, right? Let's suppose we have a basket, and in this basket we have r different colors of ball. We have r different colors of ball, and let's say drawing the color I have probability pi. Let's say we have some red colored balls in the basket, or maybe blue colors balls are there, green colors of balls are there. We have r such colors, and we have given that the probability that you draw a red colored ball have pi, or you can say let's say p1 probability. You draw a ball of green colored ball that have the associated probability p2. You draw a blue colored ball that will have a associated probability p3, right? So if you compare in case of the binomial probability where we have two kinds of object, right, either pass fail or either head tail, or you can say we have two colors of ball, red or blue. So red have the probability p, and this blue have the probability 1 minus p. I mean to say this head and tail, if you think analogous to what we have done in the binomial cases, right? We have the two different possibility of outcome, but here if you see we have r different possibility of outcome. And what experiment we are doing? We are drawing the ball from this basket, and each color, if you draw the red color, it will have the associated probability p1. So what's the probability? If you draw the ball from the basket, you will get the red ball that have the probability p1. What's the probability that if you draw the green colored ball will have the probability p2? What's the probability that you would, if you draw a ball from the basket that is green, have the probability p2, and so on? What's the probability that if you draw a ball from the basket have the blue color, that is p3, right? But in case of binomial, if you think, we have only two possibilities, right? What's the probability that you will get the head? What's the probability that you will get the tail, right? And if you think in terms of the color, you will have only two types of color, right? We will have lots of ball, but all these balls will have two types of color, and you are drawing the balls from this basket. And what's the probability that you will, and each colors, if drawing of this red colored ball have the probability p, then obviously drawing of this green color will have probability 1 minus p, right? So you get the difference. In case of binomial, we will have the possibility of outcome that are two, but in general we can deal with also the possibility of outcome that could be of r different type. Okay, now what kind of question we are going to address here? So we are going to address here, we will be asking that what will be the probability that we will get the n1 balls, or let me take an example before asking this probability. Let's suppose we are doing this experiment for, so we are drawing this ball for 7 times, right? So we have a basket, and in this basket we have r different colored ball, and we are drawing it for the 7 time, right? And each drawn is independent of the other drawn, right? And let's say that someone told you that you have n1 that is equal to 4. So in this 7 drawn, you know that, or someone told you that there are 4 purple color ball, and there are 2 blue colors ball, and there are 1 red colored ball, right? Then I will ask you that what's the probability that four balls of color purple and 2 balls of color blue and 1 ball of color red, what's the probability of getting this sequence? Right, so what's the experiment you are doing? You have a basket, and in this basket we have 3 different color ball, let's say, and you are drawing it from this basket you are drawing the balls 7 times, and someone told you that you get the 4 purple ball and 2 blue ball and 1 red ball, and the question has been asked that what's the probability of getting this? Right, so how we can solve this? So maybe we can think of a typical outcome for this kind. So maybe from the basket I have drawn the first ball and I have got the purple color. Again I have drawn the second ball from the basket, again I have got the purple color. Again I have drawn the third ball from the basket and I have got the purple, and similarly for the fourth drawn I have got the purple, and at the fifth drawn I have got the blue color, and at the sixth drawn again I have got the blue color, and at the seventh drawn I have got the red color. This could be possibility, right? Because in the basket we have 3 different type of balls and 3 different colors of balls, and we are drawing it from the basket, right? This could be possibility, and this outcome is favoring our event, right? This outcome. So, and let's say that getting the drawing the purple colored ball have the associated probability, that is p1, and for the blue we associated probability is getting the blue color have, if you have basket, if you are, what will the probability that you will get the blue color, that have the probability p2, and for the red it is p3, right? Now is this the only outcome that is favoring our event? No, we could have maybe like this: at the first drawn you get the red color, and at the second drawn you have got the purple, at the third drawn you have got the purple, at the fourth drawn you have got the blue, at the fifth drawn you have got the blue, and at the sixth drawn you have got again the purple, and at the seventh drawn you have got the purple. This is also one of the possibility, right? If I ask you what will be the, so we could have more number of sequences, and why I am doing this, you will see the benefit of this. If I ask you what will the probability of this particular sequence, we have given at the all these drawing of the balls are independent. So at the first trial we will draw the first ball, and it is the purple, and we have already told that the purple have the probability that is p1. Again at the second trial we will draw, and again we are getting the purple, and at the third trial we are getting the purple, and at the fourth trial we are getting the purple, and we are multiplying all this probability because all these probability are independent, all these drawn are independent, right? And at the fifth trial we are getting the blue, and blue have the probability p2, and at the sixth trial we are getting the blue have the probability p2, and at the seventh trial we are getting the red, and that has the probability p3. So what's the probability of getting this particular sequence? That is p1 to the power 4 times p to the power square and p cube. This is the probability of getting this sequence. And all those such sequences that is satisfying this event criteria will have the same probability, right? It, if you see, this sequence has also 4 purple, 2 blue and 1 red. 4 purple, 2 blue, 1 red. What's the probability of, what will be the probability of that sequence? That sequence will also have the same probability, right? So all such sequences will have the same probability. So what will be the probability of getting 4 balls of colored purple, 2 balls of colored blue and 1 balls of color red? So since all those sequences have the same probability, so that will be equal to the probability of one particular sequence, let's say this one, times number of such sequences. And this, how we can find this number of such sequences? We have already seen this is nothing but, this will be nothing but the coefficient, multinomial coefficient, right? Then what's the probability in this case? That will be equal to p1 to the power 4 p2 square and p cube times, here we will have the multinomial coefficient, that is c. And what is c? C is equals to 7 factorial divided by 4 factorial into 2 factorial into 1 factorial, right? So you must have the question in your mind that in multinomial probability, sorry, in multinomial, what we have found is the, so let's first recall what we have done there. So we have n distinct object, right? So here if you compare to our case, we are doing n trials, right? So we are doing first trial, you are doing second, 3, 4, 5th, 6th trial, right? We are doing 7th trial. So there n is equals to 7, and someone told that we will be getting 4 purple color, 2 blue color and 1 red color, right? So we are doing 7 different trials, right? And if this is the requirement that we should get 4 purple and 2 blue and 1 red, so basically what we are asking is that in how many way we can do that with this given trials, right? So ultimate point is that this number of doing the partition is equal to having this number of sequence, right? And this is nothing but the multinomial coefficient. So if I have to write in general the probability of getting n1 balls of color 1 and 2 balls of color 2 and so on, nr balls of color R that will be equal to how many such sequences we will have, that is nothing but the multinomial coefficient. I think here we should do few problems, so we will do in the next lecture.